All right, so get ready, because today we're going deep into some really fascinating AI research that could totally change how we think about how AI thinks. Yeah. We've got this paper. It's called Graph-Augmented Reasoning. Evolving step-by-step knowledge graph retrieval for LLM reasoning.
It's quite a title.
It is, right? Like a mouthful. But trust me, the ideas in this paper are way more exciting than that super long title.
Oh, absolutely. It is a fascinating paper. Those authors, Wenjie Yongcheng, Yingjie Wang, Wenbin and Dacheng, they're really onto something here with this research.
Okay, so let's try to break this down.
Right.
Imagine AI that can actually reason like we do, especially in those complicated fields like math or science, even on a normal computer.
Right.
Not just some massive supercomputer that's in a lab somewhere. That's what this whole idea of graph-augmented reasoning is all about.
Yeah, and it's a really big step forward because right now, even with all the advancements that we have in AI, things like those large language models, or LLMs as they're called.
Right, LLMs.
Yeah, they're still pretty limited when it comes to complex reasoning. I mean, they can write some pretty amazing text, but they're not so great at solving intricate problems that need deep logical thinking.
So they can write a beautiful poem about a math problem, but they can't actually solve it. Is that what you're saying?
Exactly. That's a great way to put it. And this is especially true for the smaller LLMs, the kind that would be much more practical for us to use every day.
Yeah.
They just don't have the same kind of processing power as those huge, massive counterparts.
Right.
They're prone to what we call hallucinations, which is really just a fancy way of saying that they sometimes just make things up.
Okay, I got it. So how does this paper try to solve this problem? What's their kind of secret weapon for fixing this?
Well, the authors propose this very interesting solution that they're calling graph-augmented reasoning.
Okay.
And the main idea is to take those LLMs and combine them with something that we call knowledge graphs, or KGs for short.
Okay.
Now, think of a KG like a giant library that's organized in a super specific way, where every single book has a fact, and each bookshelf represents a connection between those facts. It's basically like giving the LLM access to this incredible encyclopedia of knowledge, but more than that, it's about how that knowledge is actually used.
I can already see where this is going. Instead of just having an AI with a ton of data, it's like giving it the structure to actually understand all that data, right?
Exactly.
Yeah.
You got it. And the researchers really tested out this whole idea. They built a special KG just for math.
Okay.
They call it the Math Knowledge Graph, or MKG.
MKG, got it.
And to make it all work, they created a framework that they named KG-RAR, which stands for Knowledge Graph-Based Retrieval Augmented Reasoning.
Okay, I'm getting a workout just trying to say all these acronyms.
I know, right? It's a lot to remember.
But tell me more about this framework. How does it actually work?
Well, so imagine that the LLM is trying to solve a math problem.
Okay.
KG-RAR basically works in a three-step cycle. First, you have retrieving, where the LLM scans that huge MKG and pulls out any information that could be helpful for solving that problem.
Okay.
It's like looking up all the formulas and all the concepts that might be useful.
So the LLM is doing its research, gathering its tools.
Exactly. Then comes refining.
Oh.
And here, the LLM takes all of that information and starts to organize it.
Right.
Making sure that it's focused and relevant.
So it's not just blindly throwing all this information at the problem.
Right.
There's an intelligence involved.
Right. It's like highlighting the really important points in your textbook, getting rid of all that extra stuff. And then you have the last step, and that's where the magic really happens.
Okay.
That's reasoning.
Okay.
The LLM actually uses all that refined information to take a step towards actually solving the problem. It's like applying the formula that it just looked up and then actually doing the math.
Wow. So it's not just about having the knowledge, it's about actually using that knowledge in a logical way.
Exactly.
Step by step.
That's what's so cool about this.
Yeah.
It actually sounds a lot like how we humans learn and solve problems. That's exactly what is so innovative about this whole approach.
Ooh.
And then to ensure that LLM stays on the right track during that whole reasoning process, they developed another really clever piece of this puzzle. They call it the post-retrieval processing and reward model, or PRP-RM.
PRP-RM. I'm going to need a cheat sheet or something to remember all of these acronyms.
Right. There are a lot.
But tell me more about what makes this PRP-RM so special. What does it actually do?
Well, think of it kind of like a guide for that LLM. The PRP-RM can actually check if each reasoning step that the LLM takes is right or wrong.
Okay.
Even if it's never seen that specific type of problem before.
Okay.
And here's the kicker. It doesn't even have to be trained on that specific task ahead of time.
Wait, so the PRP-RM just understands what makes a step logical no matter what the problem is?
Yeah.
That's amazing. It's almost like common sense.
Right. It's a big step toward creating AI systems that are way more adaptable and don't need like massive amounts of training data for every single task. But wait, there's more.
Okay, more acronyms are coming.
To guide the reasoning process even further, they actually added this whole role-playing element.
Role-play. Okay, now I'm really interested. What do you mean by that?
So they basically gave the LLM different teacher roles. They have a responsible teacher, a Socratic teacher, and even a critical teacher.
Hold on. The AI is pretending to be teachers to help itself think better.
Yeah, essentially.
Wow, that's crazy. So what did these AI teachers actually do? Like, what are their jobs?
Well, the responsible teacher basically takes that retrieved knowledge and it turns it into structured guidance for the LLM. It makes sure that it doesn't stray off topic and it checks every step to see if it's correct.
So it's like the teacher that makes sure you're showing your work and staying on task.
Exactly. Now, the Socratic teacher takes a different approach.
Okay.
Instead of just giving direct instructions, it takes that information and turns it into thought-provoking questions. It's all about encouraging that LLM to think for itself. You know, not just giving it the answer, but kind of nudging it along to figure it out.
That's pretty brilliant. It's like the teacher who asks those leading questions to help you discover the answer on your own.
Exactly. What about the critical teacher? Have you guessed what that one might do?
I don't know. What do you think?
Well, the critical teacher is the one that looks at every single detail of that LLM's reasoning, and it points out any mistakes or flaws.
So it's like that strict teacher who grades your work with the red pen.
Exactly.
Yeah.
It helps the LLM learn from its mistakes so it can improve.
They've basically created a whole AI school within the system.
Yeah, like a little AI learning environment. It's pretty amazing.
It is. It seems like they're not just making a smarter AI, but they're actually teaching it how to learn.
Exactly. And the results they got are seriously impressive.
Okay, how impressive are we talking?
They tested this whole KG-RAR thing with all different kinds of LLMs, and they found that it made them way more accurate compared to LLMs that just used other techniques like chain of thought prompting.
Well, that's really cool. So how much of an improvement did they actually see?
One of the models that they tested, it's called Llama 3B, showed a huge 20.73% improvement.
Wow.
On a really hard set of math problems called Math500. That's massive.
So that's a game changer, right? I mean, a 20% improvement means these smaller LLMs can do so much more.
Absolutely. It really shows the potential of this approach, especially for making that kind of advanced AI reasoning available to more people. Of course, no system is perfect.
Right.
And the authors do admit that there are some limitations with this approach.
Yeah, there's always a catch, isn't there? What kind of limitations are we talking about?
Well, one of the main ones is that the whole process can be pretty resource intensive, especially if you're dealing with a really big knowledge graph.
So you can't just run this on like any old computer.
Not quite yet. But remember, even with that extra work, they're getting some amazing results with those smaller models, and they're already working on making the system more efficient.
Well, that's good to know. So computational overhead, that's one thing. What other limitations did they mention?
Another concern is that the knowledge graph itself might sometimes have information that isn't relevant.
Okay.
Which could actually lead the LLM down the wrong path.
Yeah.
You know, like getting distracted by a misleading fact or something.
So it's like having that massive library, but some of the books are mislabeled.
Yeah, exactly. It could definitely cause some confusion. But the authors say that we need to keep researching ways to clean up and filter the knowledge in these graphs to make sure that they're more accurate.
So it's a balancing act, right?
Right.
Making these graphs comprehensive, but also making sure they're accurate and relevant.
Exactly. And that's where future research is going to come in. The authors actually suggest some interesting directions for improvement, like using a technique called active learning.
Active learning. Okay, that sounds intriguing. Can you explain that a bit more?
Sure. So imagine that knowledge graph is like a living thing. Active learning basically lets the KG constantly update itself with new information as the LLM learns and sees new problems.
So it's not a static library. It's more like Wikipedia that's constantly being edited and updated.
Yeah, that's a great way to put it. It's all about making that knowledge base more dynamic and responsive, which is really important for those complex and always changing fields of knowledge.
This is so much to take in, and I feel like we're just getting started. It's really cool how much creativity is going into making AI more intelligent and more effective.
It really is. And what's exciting is that this isn't just limited to math.
Oh, really?
The authors think this graph-augmented reasoning could be used in all sorts of fields, from scientific discovery to understanding complicated historical events.
Wow. So AI could be helping us analyze scientific data or even solving historical mysteries.
Yeah, the possibilities are pretty huge. But before we get too carried away, we should also think about the ethics of all this. as these AI systems become more powerful and we use them more, we need to make sure that we're using them responsibly and ethically.
That's a super important point. We can't just focus on the cool factor without thinking about the bigger picture. But for now, let's enjoy the potential of all this research. It's really amazing.
Absolutely. It shows what humans can do, and it gives us a peek into a future where AI can actually help us understand and solve some of the biggest challenges we face.
This has been such an interesting deep dive, and I can't wait to hear more about what they do with this technology. But before we move on, let's take a minute to recap what we've learned.
Yeah, let's go over the main points.
All right, so we've talked a lot about how this graph-augmented reasoning works.
Yeah.
But let's zoom out for a second and think about what that 20.73% improvement on those Math500 problems actually means. That's not just a little bit better. It's a huge leap forward, right?
Oh, yeah, absolutely. It's a significant jump. To put it into perspective, that kind of improvement could be like the difference between an AI that can do basic addition and subtraction and one that can solve some crazy calculus problems.
Right.
It's like going from just simple calculations to actually solving real-world problems.
So we're talking AI that could potentially help scientists analyze all that complex data.
Right.
Or design new experiments, maybe even make breakthroughs in fields like engineering or medicine.
Exactly. And remember, we're talking about doing all of this with smaller, more accessible LLMs. This could really change things. You know, it could make those advanced AI reasoning capabilities available to so many more people.
That is a really exciting thought. Imagine if anyone with a decent computer could have access to AI that can help them understand and solve those super complex problems in their field. It could change everything about education, about research, even personal productivity.
It's about giving individuals the tools that before were only available to like a super small group of people. And it also shows us how important it is to explore all these different approaches to developing AI. Sometimes it's not just about building bigger and more powerful models.
Right.
It's about finding those smart ways to make them better, using external knowledge and structured reasoning.
Right. It's like moving from just brute force to something way more elegant and efficient. And I think this whole idea of role-playing within the AI is a perfect example of that.
Yeah.
It's so cool how they're creating this little mini society of AI agents in the system, each one playing a specific part in how the reasoning works.
It's a really innovative approach.
Yeah.
It shows just how much potential there is in incorporating more human-like thinking into how we develop AI. You know, it's not just about copying the way the brain is structured, but actually the process of how humans learn and solve problems.
It's like teaching AI to think more like us, but way faster. But if we take a step back and look at the bigger picture, what do you think all of this means for the future of AI? Do you think this graph-augmented reasoning is going to become the standard?
Well, it's definitely looking promising.
Yeah.
And the results we've seen are really encouraging. But it might be a little too early to say for sure if it will become the main approach. I think it definitely has the potential to really influence how we do AI reasoning in the future.
It's like we're at a crossroads, and this research is showing us this new path towards AI that's not just smarter, but also more understandable, more explainable, and much more accessible.
I totally agree.
Yeah.
And that's what makes this research so exciting. It's not just about pushing the limits of what's possible. It's about doing it in a way that benefits everyone.
I'm also really curious to see how they tackle those limitations we discussed earlier.
Yeah.
Especially the computational overhead and the chance of having that irrelevant information in the knowledge graph.
Yeah, those are some big challenges that need more research and development. Right. Finding ways to make these systems more efficient and accurate is going to be super important for people to really start using them.
I'm also really interested in seeing how they apply this to other areas besides math.
Right.
I mean, imagine what we could do if we could give AI this kind of reasoning power in fields like history or law or even ethics.
The possibilities are kind of mind-blowing.
Yeah.
Imagine an AI that could analyze historical documents and help us understand why big events happened, or an AI that could go through all those legal cases and help lawyers build better arguments.
It would be like having a whole team of super intelligent researchers working all the time to uncover new insights and solve really complex problems.
It would be amazing.
Yeah.
But it's important to remember that we're still in the early stages here.
Right.
There's still a lot of work to do before these technologies become something we use every day.
That's a good point. It's easy to get caught up in the excitement, but we need to stay realistic. But even at this early stage, it's clear that this research is pushing us towards a future where AI could totally change the way we live and work, and even how we understand the world around us.
Definitely. And that's why it's so important to keep learning about these things and be a part of these conversations, to really think about the good and the bad that can come with these new technologies.
Absolutely. And speaking of learning, we've covered a lot today, so I think it's a good time to go over the key takeaways from this deep dive, just to make sure everyone's on the same page.
Yeah, let's sum it all up.
Okay, so as we wrap up this deep dive, what's the one big thing you want our listeners to take away from this whole conversation? What's the main point you hope they remember?
I think the biggest takeaway is that this research is showing us a possible way to make AI that's not only smarter, but also easier to understand and easier for people to use.
Right. It's not just about teaching AI to think. It's also about giving it the right tools and the knowledge to think well and in a way that makes sense to us humans.
Yeah, exactly. And the really cool thing is they got these huge improvements using relatively small AI models.
Yeah.
Imagine what could happen if they use this approach with even more powerful systems.
Now that you mentioned scaling it up, what kind of real-world uses can you see for this if they can apply it to other areas like the authors talk about in the paper?
Well, just imagine having personalized AI assistants that could help us understand and solve problems in all kinds of different fields. And we could do all of that without needing those giant supercomputers.
Right.
We could have AI that helps scientists with their research or analyzes super complicated financial data, or even just helps us make better decisions in our everyday lives.
It's like having a whole team of experts right there in your pocket ready to help you with anything. That's a future I definitely want to be a part of. But let's come back to right now. For our listeners who are like, okay, this is awesome, I want to learn more about this, or even try it out themselves, what are some good resources they can check out?
Well, the first thing I'd say is read the paper itself. You can find it online. Just search for the title, Graph-Augmented Reasoning, Evolving Step-by-Step Knowledge Graph Retrieval for LLM Reasoning.
Yeah.
It's a bit of a mouthful.
It is.
But it's worth it.
And
the authors were really cool. They actually made some of their code and data available to the public.
Nice.
So if you're the kind of person who wants to get your hands dirty and really dig in, that's a great place to start.
Perfect. We'll make sure to include all those links in the show notes so people can find them easily. And as always, we want to encourage everyone listening to keep exploring these topics, stay curious, and never stop learning.
That's what the deep dive is all about. We're all about building this community of curious people who want to understand the world better.
And on that note, we'll leave you with something to think about. If you could have your own personal AI assistant powered by this graph-augmented reasoning thing, what problems would you want it to help you solve? Let us know in the comments, and hey, who knows, maybe your idea will be the inspiration for the next big AI breakthrough.
Until next time, stay curious and keep on diving deep.
We'll see you all soon, knowledge seekers.